Good day and welcome to another video of MECC for 8-1 tutorial series. And right now we are going to discuss about probability and statistics. Join me and Mia Abrinica, Cavalas Bernadette, Del Pilar Adrian Cliff, Escalera Jake, Benito Dasa, and Oro Roy Christian as we learn new techniques on how to solve problems about probability and statistics. Without further ado, let us now hop on to the first question.
Hi, I'm Abrini Kabuhia, and I'm back to discuss another word problem about probability and statistics. And let us start off with this first question, which states that Maria has a probability of hitting the target at 2/3, while Mario has a probability of hitting the target at 2/5. They both fire at the target, and we are to find the probability that one of them hits the target. And for this problem, I will be presenting two approaches on how we can solve it. So we are asked to solve for the probability that only one of them hits the target, and we are given the respective probabilities. And the first approach we are going to use is the formula for joint probability that is non-mutually exclusive with common outcomes. We are going to use this as the event stated can happen at the same time and that hitting is the common outcome of the event. But instead of using the formula for the probability of A or B, we are going to use the probability of A, X, or B because we shouldn't have alike outcomes based on what was asked on the problem. So we can see here that the probability that only one hits is equal to the probability of Maria plus probability of Mario minus 2 times the product of the probability of Maria and probability of Mario. We then substitute the values we have and get the probability that only one hits, which is 8/15, or approximately 0.5333. And the second approach is by using this formula, which is from the complementary probability. And we use the formula of complementary probability that is the probability of A to happen is equal to 1 minus probability of A to not happen. After we get the values of probability of A to not happen and probability of B not to happen, we are going to use this formula, and wherein we add the product of PA and P naught B and P naught A and PV. We then substitute again the values we have and reach an answer of 8/15, or approximately 0.5333. And for our next problem, we have this problem which states that the chance the both components of a two-stage rocket will function correctly is 0.95, and the reliability of the first stage is 0.98. And we are asked what is the reliability of the second stage. So we can say that the two stages are mutually independent with each other. Therefore, we are going to use the formula of independent probability, which is the product of the probability of the first stage to happen and the second stage to happen. But we are asked to find the probability of the second stage. Therefore, we are going to divide the probability of both stages to happen over the probability of first stage to happen. And we can get the probability or reliability of the second stage to happen at 95/98, or 0.9694.
Greetings everyone, my name is Bernadette Cavalas from Group 1, and here I am again discussing two problems with solutions, and this time about probability and statistics. So go with me and enjoy. So the first question is, a container contains 2 blue handkerchiefs and 2 white handkerchiefs. 2 handkerchiefs are drawn at random. Find the probability that they have the same color. So for the solution, we can solve the problem from the independent probability, in which the outcome of the other doesn't affect the other. Then, so we can solve the problem from the formula P of A and B is equal PA times P of B, where P of A is the probability of event A may happen, P of B is the probability of event B may happen. So what is asked in the problem is to find the probability that they may have the same color. So, since there are two outcomes to have the same color, one is blue and the other is white, we can denote that, or to let P of A is equal to the draws that draw all blue and P of B that draws all white. So in solving, we do have here the first step, which is to solve the event that draws all blue, or P of A. So that would be P of A is equal to total blue handkerchiefs over total handkerchiefs equal to 2/4 or 1/2. Step 2 is to solve the event that draws all white. So that would be P of B, which is equal to total white handkerchiefs over total handkerchiefs equal to 2/4 or 1/2. Then, the next step, or the last step, is to solve the probability of getting the same color from first draw. Since we do have here the result of the event that draws all blue, which is 1/2, and the event that draws all white, which is equal to 1/2, we can then say that 1/2 times 1/2 is the probability of getting the same color, and that would be equal to 1/4 or 0.25. I hope we get the same answer. So let's proceed for the second problem. What is the probability of getting two heads if you toss a fair coin twice knowing that the first toss resulted in a head? Okay, you can just pause the video to answer the question on and play it once you're ready. With that, let's proceed. To solve this problem, we can use the probability of an event, since an event is the chance that the event occurred. So we can use the formula of the probability wherein equal to the number of outcomes, the favorable number of outcomes, over the total of outcomes. We know that when a coin is tossed once, that there are only two outcomes, heads or tails. And what is asked in the problem is the probability of getting two heads when the coin is tossed twice. And in the problem as well, it was given that the first toss, we are already getting the head. So the head is given already in the first toss. Since there are only two outcomes when a coin is tossed, we can observe, or we can say that the possible outcomes knowing that the first toss is heads are heads, 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 tail. Thus, there are two total outcomes. From the two total outcomes, we can then observe the two heads are obtained only once when the coin was tossed twice. Thus, the favorable outcome is 1. With that, since we already have two total outcomes and one favorable outcome, we can then substitute that from the formula wherein the number of outcomes, or the favorable number of outcome, is 1 and the total of outcomes is 2. Thus, the probability is 1/2 or 0.5. That's all, and I hope you learned something. Thank you.
Okay, so for our next problem, there is a 40% probability that an engaged man commits cheating in a relationship, while 50% probability that an engaged woman commits cheating. The probability that a man commits cheating, given that his fiancée does, is 70%. Find the probability that at least one person of the engaged couple will commit cheating. So we are trying to look for the probability that at least one of them will cheat. We are already given with a probability that the man cheats given that his woman does, which is equal to 70%, and then we can get that by dividing the probability that both man and woman cheat to the probability that a woman cheats. Rearranging our formula, we can multiply the probability of the man with respect to the woman, which is 70%, to the probability of the woman cheats, which is equal to 50%, to get the probability that both man and woman cheat, which is equal to 35% probability. Next up, we are trying to look for the probability that a man cheats while the woman does not by subtracting the probability that a man cheats to the probability that both man and woman cheat. Plugging in our values will give the probability that a man cheats while the woman does not, which is equal to 0.05. Next up, we are trying to look for the probability that the woman cheats while the man does not by subtracting the probability that the woman cheats to the probability that both man and woman cheat. Plugging in our values will give the probability that a woman cheats while the man does not, which is equal to 15% probability. Thus, to get the probability that at least one of them will cheat, we can add the probability that a man cheats and woman does not, the woman cheats and the man does not, and both man and woman cheat to get the probability that at least one of them will cheat. Plugging in our values will give an answer of 0.55. Stay loyal to your partners.
We have the problem. Two cards are drawn at random from an ordinary deck of 52 cards. So we have to find the probability that one is spade and one is heart. So this problem will have two cases. So for case one, spade first and then heart. So we have PA is equals to 13 because there are 13 spade cards in a deck over 52 times 13 over 51 because the replacement there is no replacement, so the number of the total cards in the deck will be decreased by 1. So 13 over 51 and we have 0.063725. For the second case, we have heart first and then spade. So PB is equals to 13 over 52 times 13 over 51. Same with the case 1. So to get the probability, we have to add the both cases. So PA plus PB, 0.063725 plus 0.063725, it will be 0.1275.
Hello, my name is Dasa, and today I'm going to discuss one problem involving probability and statistics. So the question goes, a mechanical engineering student is taking a 15-item true or false type examination. If the student guesses at the answers, find the probability that he gets a perfect score. So this problem is an example of a repeated trial probability wherein the formula or the solution for this is equal to the combination of n taken r at a time multiplied by the p to the power of r times q to the power of n minus r, where p, the big letter P, is the probability that the event will occur exactly r times out of n trials. And the small letter p is equal to the probability of success, and q is the probability of failure. So in the problem, the small letter p is the probability of getting a correct answer, which is equal to 1 out of 2. We all know that the question stated that this is a true or false type of examination. So therefore, we have two choices, the true and the false. And to get a correct answer, we only need one answer out of the two choices. Therefore, we have a 50% probability of getting a correct answer. And similarly, we also have 1 out of 2 probability of getting a wrong answer. And the big letter P is the probability that the mechanical engineer will have a perfect score by getting 15 correct answers out of 15 questions. And with this, we know that n is equal to 15 since there are 15 questions, and r is equal to 15 also because we need to get 15 correct answers out of those 15 questions. So by substituting these values to the formula, P is equal to NCR times P to the power of R times Q to the power of N minus R we need to multiply the combinations of getting 15 correct answers out of 15 questions multiplied by the probability of getting a correct answer, which is 1/2 to the power of 15, and the probability of getting a wrong answer, which is 1/2 to the power of 15 minus 15. So we all know that 15 C15, or the combination of 15 out of 15 questions, is equal to 1, and also any number raised to the power of 0 is also equal to 1. Therefore, the answer for this one is equal to 1/2 to the power of 15. This can be simplified and solved, so we get a value of 3.051757 to the times 10 to the power of negative 6. So that is the probability that the mechanical engineer will have a perfect score by getting 15 correct answers out of 15 questions with pure guesswork. And that's all for this question. Thank you.
For the next question, there are 5 cars in a race. A person chooses 2 of the cars at random and bets one of them. Find the probability that a person picked the winner. For this problem, we have the equation P equals E over S. So we all know that probability is defined as the means of expressing varying degree of confidence, in which it is calculated as the ratio of the total number of ways the event can occur, or the total number of successful outcomes to the total number of possible outcomes. So in the problem, our E, or the total number of successful outcomes, is 1, since there should only be one winner. And for our S, which is the number of total possible outcomes, we have the combination of 5 and 2, since possible number of ways of randomly picking 2 from the 5 cars. So we have to calculate the combination, which equates to 10. So the probability that a person picked the winner, as we substitute these values in the equation, so we have 1 over 10, or equals to 0.1. 0.1 is the probability that a person picked the winner if she chooses 2 cars out of the 5. So for the next question, a wheel of fortune is divided into 3 equal parts. Each part is named 1, 2, and 3. What is the chance of landing on a 3 if you know the arrow landed on an odd number? So we have the same approach from the previous question. We have again the ratio of the number of successful outcomes to the number of total possible outcomes. So in the problem, our E is 1, since there's only 1 3 in the wheel. And our S is 2, since we know the arrow landed on an odd number, so the possible outcomes are 1 and 3. So the chance of landing on a 3, we substitute this in the equation. So we get 1/2, or equals to 0.5 possibility that the wheel or the arrow will land on a 3 if we know that the arrow landed on an odd number.
So good day everyone, I am Roy Christian Oro and I will be reporting about this problem. So, a ball contains 5 red, 3 blue, and 2 yellow balls. If you draw 3 balls, what is the probability that less than 2 will be blue if you draw with the replacement? So if we try to visualize the problem, this is what it would look like. Now, to get the probability of getting a blue ball, it's just equal to the number of successful outcomes divided by the total possible outcomes, which is equal to 3 divided by 10. So now, since we want to get the probability of getting less than 2 blue balls, we have to add the probability of getting 1 blue ball and the probability of getting 0 blue balls. So for that, we will use this equation, the repeated trials formula, because there is replacement, where n is the number of balls that we will draw and r is the number of successes. So for this, our success is a blue ball. So first we will get the probability of no blue ball. So n equals 3 and r, number of success, is 0. The probability of getting no blue ball is the complement of p, which is 1 minus 3 over 10, and that will give us a value of 0.3430. Next, we will get the probability of getting 1 blue ball, which is, in this case, r, the number of success, is now equal to 1. The same probabilities will be used for p and q, and n is still 3. So that will give us a value of 0.441. And if we add the 2, that will give us a value of 0.7840. That is all. Thank you.